In order to compare and predict with galvanic cells, we need to have a standard. And so just going through some terminology and how the standard's set up. So the word electromotive force or voltage, electrode potential, all of those terms we're going to use interchangeably. And the standard hydrogen electrode SHE is what we use to compare all the different types of substances. So having a look at what the SHE looks like, it's basically just hydrogen, and it's been standardized here, so it's at 25 degrees, 100 kilopascals of pressure. It's an inert electrode, so it's a platinum one. There is 1 molar hydrogen ions in the solution, and the gas is being put in at that pressure and bubbling out, and that is the equilibrium that's reached. So there is a certain amount of hydrogen gas and hydrogen ions all being constant in this situation here. Now I've just updated this slide and double checked it just so that you can do some more complex questions. So your entire redox tables, reduction potential tables, they could be written as oxidation, is done in this form, and I've double checked it with the equipment. So you've got to make sure that this is the neg and this is the pos. The electrons do go in this direction. So zinc actually does go in the opposite direction, so it has a negative value. And if it's got a positive value, then electrons have been flowing in this direction here. And so just be aware of that. So that's how the setup is. So conventionally, reduction occurs at the cathode and we put it on the right. But in this case, because some are more greater reducing or oxidizing agents than hydrogen, there'll be various directions, left and right. Okay, and so if you're really trying to stay on the edge and put yourself up slightly higher up the bell curve, I just make sure this is clear enough so you can deal with slightly more trickier questions than perhaps you'll get in the ATAR to train you up to potentially get full marks on your ATAR. And the same can be done with all the other metals. So this one's just a copper one this time. And so the standard hydrogen electrode is set up and compared to the copper, and that's how we get our reading of plus 0.33 volts for copper. And so all those values will be put into a table, which is the next slide or the next video.